So let's look at an example problem for vaporizing A and convective mass transfer. So let's take a few minutes to read that. A large volume of pure gas, B at 2 atmosphere pressure, is flowing over a surface from which pure A is vaporizing. The liquid A completely wets the surface, which is a blotting paper. Hence, the partial pressure of A at the surface is the vapor pressure of A at 298 K, which is 0.2 atmospheres. The Kc prime there has been estimated to be 6.78 times 10 to the power minus 5 kilojoule more per second square meter per mole fraction. Calculate Na, the vaporization rate, and also the value of Kc and Kg. So this is a case of A diffusing through B, where the flux of B normal to the surface is 0. Because B is not soluble in liquid A. So data there, PA1, PA2, the temperature, then Ky is given there, 6.7 times 10 to the power minus 5 kg mole per second per squared. So with mole fraction, we've seen that Na is equal to Ky Ya minus Ya2. Then converting partial pressures into mole fractions, we have Ya1 equal to Ya1 equal to Pa over P there is indicated. Then our Ya2 same equals to 0. Why? Because Pa2 over P is equals to 0 over 2 there, which is equals to 0. Right. However, Ky prime is related to Ky from a table 1.61 by Ky Yb log mean equals to Ky. So Y log mean B given here is indicated there. So then how do we calculate our YB1? So YB1 there becomes 1 minus Ya. The Ya is that we've calculated before. Then we calculate YB2 again. It's the same, where our Y2 is 0. So when we substitute the value of yb1, yb2 into log mean yb, we obtain 0.5. All right. Then making use of the relationship ky is equals to ky prime over ybm 6.78 times 10 to the power minus over 0.5. We obtain ky equal to 7.138 times 10 to the power minus 5. Then also from the same table, kgyb lmp is equals to ky yb log mean. And solving for kg and substituting nonce, we obtain this equation. We obtain this is what we get, and we get 3.522 times 10 to the power minus 10. As indicated there, if we were to change this to units with atmosphere, then it becomes 3.569 times 10 to the power minus 5. So calculating our flux NA there, we get this equal to 7.5. We substitute for this, for this, for this. So NA using kg PA1 minus PA2, we also get 7.138 times 10 to the power minus 6. It's still the same, even if we use different units. So note that in this case, since the concentrations were dilute, YB is close to 1 and KY prime differ very little. Thank you.